in Labs. My name is Gwen Pallier, Product Line Manager in charge of laser processing application.
My name is Jeanne Brousseau and I'm in the technical team.
Today we want to show you how CANUNDA-USP PureBeam works. Let's go! So with Jeanne we want to start by showing you a very simple setup. So there is a source, then we have two injection mirrors. We extract a little bit of the light, which is going onto a first camera and to a first computer. Then actually the light is injected into our CANUNDA-USP PureBeam module, and it's going to a second camera, which is on the other computer. Let's start the demo now, please, Jeanne. Could you please move the source quite a lot, about a waist? And the idea is to be looking at what's happening when we are not stabilizing the beam and what's happening when we are stabilizing the beam. Okay, let's look more into details to the screens and to the numbers. Can you please tell us what are the beam dimensions?
The waist of the beam before the module is 25 microns and the waist of the beam after the module is 35 microns.
How much the beam has moved before and after the module?
The beam has moved of 20 microns before the module and of 2 microns after the module.
Okay, excellent, only 2 microns. So it's more than 10 times less movement. We are really stabilizing the beam.
Yeah, it's really great.
So that's the real principle of CANUNDA-USP PureBeam. When the beam is moving at the input, it's not moving at the output. And it's fully passive, as you can see, there are no cables at all. Let's continue now the demo with fiber launching. After our CANUNDA-USP PureBeam, the beam is going to 2 mirrors and then injected into the photonic tools module. This module injects into that hollow core fiber, which is going to that laser head and to that camera, and we are looking at the camera onto that computer. Hollow core fibers are really beautiful, but they are very sensitive. If the beam is not injected perfectly into the core, when you have high power, you are actually damaging the fiber. Can you show us now what's happening when the beam moves without stabilization?
When we are moving the mirrors, we can see the light goes into the higher modes, which would damage the fiber.
Can you show us now what's happening when the beam moves and there is stabilization?
We can see that only the transmission is decreasing.
With CANUNDA-USP PureBeam, no light in the higher modes.
And your fiber is safe.